So very good morning. So now discussed magnetism and electromagnetism. So that magnetic materials. So any material that can be magnetized by applications of external magnetic field is called magnetic material. So that materials are a substance upon which being introduced into an external magnetic field, so they themselves become source of additional magnetic field. So in 1845, Michael Faraday discovered that the magnetic materials can be broadly classified into three groups, namely diamagnetic, paramagnetic, and ferromagnetic materials. So that magnetic materials play a prominent role in the modern technology. So they are widely used in industrial electronics, entertainment, electronics, and computer industry. So the development of quantum physics will help us understand the phenomena of magnetism to a great extent. A large number of devices utilize the mainly two magnetic phenomena, ferromagnetism and ferrimagnetism. So the basic understanding of the magnetic phenomena is essential to the appreciate operating principles of the various magnetic devices. So we know that the current through the circular coil produces the magnetic moment along the axis of coil. So when the electrons revolve around the positive nucleus, the orbital magnetic moment arises. So similarly, when the electron spins and spin magnet moment arises, so magnetism arises from the magnetic moment or magnetic dipole of the magnetic materials. So both the orbital and the spinning motions of every electron in an atom produce a magnetic fields. And magnetic field is assumed to consist of lines of magnetic forces. So these lines of forces are assumed to travel extremely from north to south pole of the magnet. So hence the magnetic lines of forces are defined as the continuous curve in a magnetic field. So the tangent drawn by the curve gives the direction of for the resultant magnetic intensity at the point. So the all magnets have the north pole and south pole. So like poles ripple, like poles is a ripple, unlike poles are attract. And then magnetic flux, the total number of magnetic lines of force passing through the surface, so is known as the magnetic flux. And magnetic induction and magnetic flux density, the number of magnetic lines of force passing perpendicularly through the unit area of the cross section. A compass needle is a small bar magnet that can be freely rotated. A compass needle always points north or rather than is the north seeking. And the core of Earth acts like a gain Bohr magnet. And historically, people define the north pole of a magnet as the end of the points north. A compass needle always points north. That means the geographic north pole of the Earth is really is the south magnetic pole since attracts the north poles of magnets. And the northern lights and the southern lights are a result from the interaction between the solar wind and the earth magnetic field is the air glow. And microscopic groups of atoms with aligned magnetic poles. So that macroscopic magnetic properties of substance are consequence of magnetic moments. So associated with the individual electrons, each electrons in an atom um, that originate from the following two sources: orbital magnetic moment of electrons, spin magnetic moment of electrons. So that means magneticide and not magneticide. So we know that the electrons in the an atom revolve around the nucleus in the different orbits. So basically there are three contributes of the magnetic dipole moment of an atom. And the orbital motion of the electrons, it is called as a orbital magnetic moment. Its magnetic is always small. Spin motion of the electrons, and it's called as the spin magnetic moment. The contribution from the nuclear spin, that is due to the nuclear spin angular momentum, since that is a nearly 10 power 3 times smaller than that of the electron spin, it is not taken into the consideration. And magnetic materials, in which the domains will line up order of magnetic field, so for example iron, cobalt and nickel. Thank you. See you in next series.